All right, we're going to find the number of atoms of nitrogen in 1.2000 grams of C14, H18, N2O5. So we circle what we know, 1.200 grams. Underline what we're trying to find, atoms. So our pathway has to be grams to atoms. I look on my mole island sheet. I know we're starting off with grams. And then we always have to go to that central hub before going to particle a liter island from grams. Stay in those shipping lanes. So that means I'm going from grams to moles. And then from moles, I'm going to go to particle island. Okay, so now I have to think, when I'm going to particle island, I have C14H18N2O5 over here. That's a molecule, which means Avogadro's number is going to be in molecules. So I can't skip right to atoms because I'm starting with molecules. So on particle island for molecules, I have to go to the mole stop first, or the molecule stop first. And then once I'm at the molecule stop, then I can go to the atom stop. Only if this was an element could you go right to atoms. Okay, so now we have our pathway, grams to moles, moles to molecules, molecules to atoms. What is our unit conversions? We're going to have 3 because we have 3 arrows. Grams to mole, it says use molar mass for my first unit conversion. Moles to molecules, it says use Avogadro's number for my second unit conversion. And molecules to atoms, we're going to count for our third unit conversion. So now we have a pathway and we know what unit conversions are on each step of our 3 conversions. We write what we know, 1.2000 grams C14, H18, N2O5. Put that over 1/3 minus grams is in the numerator. So that means here grams is going to be in the denominator. Molar mass is always grams and moles. I got to go take a little side trip here. Figure out molar mass. There's 14 carbons. Carbon on the periodic table is 12.01. There's 18 hydrogens. Hydrogen's 1.01 mass on the periodic table. 2 nitrogens. Nitrogen 14.01 on the periodic table. And oxygen there's 5 of them at 16.00. So when I sum up all those individual masses for each atom, I get the total of 294.34 grams for the entire mole. So moles in the molar mass is 1, and the grams is 294.34. So now, when I cancel, grams in the numerator, grams in the denominator, I'm now finished with this because I used molar mass. And now if I stopped here, I would be at moles. All right, so I'm on the right track. Now from moles to molecules, I have to use Avogadro's number. All right, so Avogadro's number is 1 mole equals 6.02 times 10 to the 23rd. Molecules in this case. 1 mole is on the top, so 1 mole goes on the bottom. 6.02 times 10 to the 23rd molecules goes on the top. Make sure you at least abbreviate up to the C so you don't get confused. What cancels out? Moles, which makes sense. We were getting rid of moles. What is my answer now in molecules? Which is true, molecules. But I'm not done yet. I still have my third unit conversion, so I'm going to have my third unit conversion here. Molecules is in the numerator, so molecules goes in the denominator. And now it says atoms of nitrogen. Well, how many atoms of nitrogen are there? There's 2. 2 atoms in 1 molecule. 1.2000 times 1 times 6.02 times 10 to the 23rd times 2 divided by 1 divided by 294.34 divided by 1 divided by 1. 4.909 times 10 to the 21 atoms of C14, H18, N2O5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Oh, I need to go one more. 4.9090 times 10 to the 21 atoms is our answer.